So let's move to the next one. So I'm more than happy to present him and to introduce you to JJ Merelo. He's a free software developer. He's a teacher at the University of Granada. And most of his work is basically GitHub, so you can follow him in github.com/JJ. He collaborates in the development of Raku language, and sometimes he writes also fiction and non-fiction, also free, of course. You can check it. He supports open science through the use of free software and open data research. So with that said, welcome to present you. So feel free to start sharing your screen or whatever you want.
Hi, how are you doing? So I'm gonna share my screen. Here you go. Okay, can you see the screen? Right now? Hello, my name is JJ Merelo, Juan Julián Merelo. I am right now in Motril, Spain, which is a very nice place. You can go out. And it's sunny today, so it's really bad to be inside here. But anyway, we're going to try and have some fun talking about open science using RMarkdown. This is the whole talk is right here in this URL. You can check me out at this Twitter, also Telegram or Gmail or anything like that. And this is my own space in GitHub. So I got it early on. So that's why I have a double letter. So let's see. Science needs to be open. So what does that mean? I think that it's really, really important for science to be open. Not only because science does some stuff that's important for society, but also because it allows society at large to be involved in the process of science. So that's the whole point about it. When there is a big crisis like this one, or simply in the regular work of any scientist or anyone who does something that can be published, and I think it's very important to have it open and to keep it in the open. And you need to open your software, of course, because I mean, if you don't use free software, you're not going to be able to reproduce what someone else is doing. And not only you need to use free software, you need to free your code, but also you need to use free software for making anything related to science. That means don't use MATLAB. MATLAB is hell. You need also to open your data, because if you are kind of having yielding some result or publishing some result, the data needs to be open. You need to publish the data you are using for achieving your result, for achieving your results. Of course, your publications. If at the end of the day, what you have is a very exclusive agreement with some big conglomerate of a publishing company, people are not going to be able to get it, and people are not going to be able to get something out of it. We always say that science is done on the shoulders of giants, but if those giants are behind a paywall, it's going to be very difficult to stand on any shoulder at all. We're going to try and do it as easy as a fried egg with using something called RMarkdown. RMarkdown is probably not very popular, but for me, it's the easiest way to go from idea to publication. And that's what I'm going to talk about right here, right now. I'm also using GitLab. Why? Because, of course, if you do something, you need to make it open from the get-go. If it's not open from the beginning, if it's not in an open repository, well, it's not exactly the same. Open science is about sharing your work and having the society engage with your work from the beginning. So if you do everything in GitHub because it's convenient or you like it or whatever, and then you say, okay, so I'm gonna open it at the end, it's not the same. So you gotta be open from the beginning. And science is not publish or perish. I work in a university, so I am a professor at the university, and people mostly think that science is publishing or getting something published in the top tier journals in your specialty. It's not exactly that, but still, you need to release something. So it means that at the end of the day, you need to have something that's released. You need to have something that's out there that people can check out. we might call it publish, we might call it release. At the end of the day, if you do open science, it's very similar and it involves a lot of software development. So I think that release is probably the right metaphor for talking about that. Code is science. That's also very important. You will always use some kind of code for publishing. It can be, if you're in computer science, you're going to create a program, a script, or a library, anything like that. If you do something else, still you will use some workflows, for instance, that you are going to repeat to achieve the result. And the most important thing about code science is that it needs to be checked as if it's actually code, right? So it means that you need to test it, you need to create releases out of it, you need to have it in a source control and everything, and that's very important. That's also manifesto. It's called Code Science. Please check it out. It's very interesting, and it also talks about best practices that you can do when using coding science, which is almost always. And also public repositories. You need to have it in a public repository. You need to use GitHub or GitLab or whatever suits you the best. Everything I do is in GitHub, so if you can check out my GitHub repositories, you will see that every single paper I'm working on, and it's going to be right there. And every interaction I have with my colleagues, and it's going to be there. I'm going to use issues, and I'm going to use milestones, the whole 9 yards. And what's a milestone? A milestone is something that's going to produce a release. That means in the case of a paper, it's going to be something that you're going to have before a conference or before you submit something to a journal. What's an issue? It's something that you need to fix. For instance, you get some feedback from reviewers. You might put it in an issue so that you can interact with it and eventually produce some changes in your code base. In this case, it's going to be a paper and code. Also, you're going to have pull requests, so people can just drop by and say, okay, so this paper is extremely interesting. You have this very ugly typo in the title. So he or she can make a pull request and it can fix your stuff, which is what open source is all about. And it's going to be very easy to do it with RMarkdown. There are many other ways of doing that, but in terms of, as I said, idea to getting something published, RMarkdown is by far the fastest way of doing it. And also RMarkdown is much more than just R and Markdown. I'm gonna try and explain that in the next few minutes. You know Markdown already, so it's a very easy way to create documents. It's a way for structuring and marking some parts of the document so that they stand out or whatever. And R is a language. That's it. It's a language. it's not nice by any stretch of the term, but it's a language. What are Markdown documents? So there is a specific way of. I'm not really sure that there is a standard. It's a de facto standard probably, but our Markdown documents are actually a part which is YAML metadata. This is something that you put on the front of the document so that we know what the document is about. Then there is Markdown text, and then there is fenced R code. This is the nice thing because Markdown has a specific way of fencing code so that you know that some part of the document is code. R Markdown is exactly that. So the only thing you need to do is to put some code within a fence, within a Markdown fence, and it's going to be interpreted as if it were part of the document. Here's the metadata, for instance. You're going to have things that are metadata, like title, author, and date. So that's going to be the title of the document you're going to produce. The author is going to be whoever wrote the stuff, and of course the PhD advisor and the boss of the department and the minister of whatever of the country, and whoever cleaned the thing. Yeah, no, don't take my toilet paper, please. I need my toilet paper. Yeah. Somebody was taking away my toilet paper from me. Oh, that's bad. I have my very own roll of toilet paper over here. Antique. Anyway, so this is more metadata. So the HTML document is well, it's a different way of producing it. So what you're saying here is that I'm going to produce an HTML document. You can also produce PDF, and you can also produce an open document. And then this is a nice thing. You can just insert bibliography in the usual way that's on in LaTeX or whatever. It's called bibtag. So you can have some bibtag and some bibliography that you want to insert. And it's going to be very easy to do it there. Then you define the abstract. So you write some stuff here and, well, some other stuff, right? So this is basically it. This is going to be in the front. As you see here, you're putting the 3 dashes, which indicate that it's a YAML document. And then you set the stuff up. So remember, this is a document, but it's also a program. So you need to put your sheet together at the beginning of the document. This is a fence. You know that this is a Markdown fencing code, and then you put some metadata on every piece of code, which are called chunks, by the way. So you give it a name. You need to give it a name because well, it's going to produce some it's going to be extracted out of that, and they're going to produce a file. You need to have a unique name for like an ID for every chunk, and then you have to also some specific chunk metadata. In this case, what I'm saying is include equal to false. This is basically our code, and you are telling it, okay, I don't want this to be included in the document. You have the choice of putting that code in the document. You might want to do it just in case when you want to show what you are doing step by step. But in this case, I'm saying no, do this, but don't put that into the final document. So I include all kind of libraries. The good thing about R is that you have so many libraries that you can use to process data. And the thing is that the experiment is the paper. So the science is in the paper. So you are using some raw data. In this case, I'm taking some user some CSV data out of a repository in the Johns Hopkins University, and I'm taking it directly. So I'm taking it directly from there, and every process that's being followed by the data, and every data processing, data managing that I'm doing, it's right there. So that's a good thing. It's open science because it's this is open source, and it's in the same piece of in the same file where you're producing the paper, right? So this is what it's weird. It might look weird. It's an acquired taste, so eventually you get used to it. It's not so ugly after all, but well, I mean, it's a so this is something that you put at the very beginning of the paper because you need to do some initial processing. In this case, what I'm doing is I'm creating some variable which is called world.confirm, and that variable includes some data taken from there, which has been processed in a particular way. These are libraries. TDR is part of what is called a tidyverse. A tidyverse is a set of libraries written in R that allow you to work with data and represent data. ggplot2 is a very nice library which is used for plotting stuff, and ggthemes is something I like. It adds themes to your charts, and it makes them easier to interpret and more beautiful. I also got one theme that's called Tufty, as in the guy Tufty who was the guru of charts, which is the one I use all the time, right? This is some actual code, right? And this is something that's going to be run when you produce your paper. And this is something which is called literate programming, right? So this is together with the paper itself. So we got some Markdown stuff here on top on the bottom, and then we got some code right here, and that's called literate programming. So literate programming is a way of putting together code and comments to the code, or doing something which is totally different, which is producing a document that's at the same time something that you can print and something that you can run, something that you can obtain a result out of it. And this was introduced by Donald Knuth, which is great. Initially, it was called Web Language, WEB language. He said that he was in the 80s. He was calling it WEB because that was a name that wasn't taken by any language. It was the only three-letter acronym that hadn't been taken so far. Of course, it was 84. And then there are different versions of web, depending on the language that you mix it with. This is an example that I just got from Donald Knuth's website, which is actually part of a document that produces also an adventure game with NC. And you see here that you put an at sign at the beginning of every paragraph, and this would be the text, right? And then you will have something like code, which you will produce using also the at sign and some angular brackets and then some equal, and this will be C code, right? So it's a very nice way because at the end you have a document and also you have the code for an adventure game. And this is the C code, so it's defining some enum or whatever, and then it's also creating some kind of signs so that you create something that then you can use in your text, whatever. This is pure C code, right? So this is nothing fancy. And then he introduced some terminology that we're going to use later. He talked about tangling or tangle for creating something that was a compilable source. So you got, we'll call it today something like transpiling because it's what it does. So it's producing a source out of a different source. In this case, tangle is producing C source or of C web source. And weave is going to produce a documentation, so probably later in the case of Knuth. In our case, it's going to be Markdown. So if you do a tangle, you're producing source. If you do a weave, you're going to produce documentation, right? Which is why the program that's going to be used for Markdown is called Knitter. So everything you're going to see here in this environment is related to weaving or creating, knitting or creating some kind of stuff with clothes or creating things. So this is particularly called Knitter. It's a very nice library, which is written in R, and produces all kinds of things, not only with RMarkdown, but also with LaTeX. There is a similar thing for Python, which is called pweave. Once again, we are using the same milieu of knitting and doing stuff with needles and with threads, right? You can do that from the command line of RStudio. I particularly like RStudio because it's got all kind of nice things, like you can check data in a pane. You got different window panes, and you can see directly the result. And you can do stuff like this. You can also embed charts seamlessly. Not only you can run the program, but the good thing about these papers is that you got to produce charts, or you can insert some graphics in it, and you can do it very, very easily. In this case, what I'm telling it is, I'm saying it echo equal to false, which means that this part of the program is not going to be included into the final thing. And also, this one was producing some messages like saying this data is missing or whatever. So I'm telling it to not include it there. So if I use this and I use it from RStudio, I'm going to produce something like this. So this is an actual screenshot from RStudio, and it's, if you just click here in this little arrow or play sign, you're going to see it down below. So it's very easy to debug, and it's very easy to be very productive and do stuff very fast. And then eventually you can publish it, and you can publish it openly directly from RStudio. There is just a button that says publish it in RPubs, or also in another place that's called RS Connect. It's not really important, but the thing is that right from there, if you open an account in RPubs, you can publish it and republish it just with a click of a button. It's very, very easy. If you don't want to do it there, you can do it also in Figshare, or you can do it in Archive if you got an account in Archive, or anywhere, but it's really important that at the end of the day you produce something that's published, or you can just do it on your website. So it's no big deal. You're producing HTML, so just put it there. The thing about RPubs is that, well, you got a permanent URL, which is something that's totally independent of your repository. The thing about Figshare is that you can get something which is a unique identifier for your paper. You can also very easily publish, for instance, PDF or something like that. The next thing about RPubs is that it's really HTML, so you can produce active websites with animations. You can also produce pages or tables which are active tables. You can include any kind of thing in RPubs, which is why I say that RMarkdown is much more than RMarkdown. So you don't need to produce a very static, ugly, old-fashioned PDF. You can do so much more with it. Science ain't gonna open itself. You need to open it. So just do it. Open your science, produce stuff, process data, publish it, and do it using RMarkdown. Thank you very much. That's it.
Great. Thank you very much, JJ. It was a very good one.
Thank you.
So we have a couple of questions. We can move forward with that one. So the first one is, what's the overhead for you as a researcher of adopting these tools? Does it make much of your time to set everything up, tweak stuff and everything?
It doesn't really. I mean, once you are used to it, it's just you can just open RStudio and then say open project, and then say open an RMarkdown file, and that's it. You probably already have the bibliography. You already have everything. If it's everything, it's in GitHub. I mean, it's really nothing. I mean, compare with other setups like using Dropbox or mailing stuff up and down using email. This is really nothing. The overhead is nil. I mean, I have literally written a paper in a couple of hours using this.
Okay, great. The other question here is, do you know good resources to learn R?
No, that's a short answer. The long answer is that there are very nice user groups, probably all over the place. Usually people in Stack Overflow are really helpful, but R is a big language. It's a very, very big language. There are also some, I wouldn't say silos, but there are some compartments of R like tidyverse, which are very specific and are big. Best advice would be to just dive into there, and if you have any problem, just ask the question in your closest community, or just using Stack Overflow. They are really very helpful. And I mean, I really didn't know R a couple of years ago, so I really put it up by my bootstraps, and it wasn't that hard, even for an old man like me.
Oh no, you're not old. Yeah, so another question here. It's for people who used to use MATLAB as a tool. Is it easy for them to move into R?
Don't use MATLAB. Just don't. I mean, it's not a matter of being easy. It's just you shouldn't use that. I mean, you have your university paying through their teeth for MATLAB every single year, 7,000 euros, 10,000 euros. That's
I think
short answer. But the long answer is probably using the stuff like Matplotlib and Python would be an easier thing for people who feel obliged to use MATLAB. So R is probably a little bit farther away. I would really advise people to get into Python and Matplotlib. It will be easier for them.
So I don't know if it's clear, but guys, don't use MATLAB. It's something he already said. Cool. So no more questions so far, JJ. Thank you very much.
Thank you very much for setting this up.
Thank you, and see you now. For we are going to have a break for the next break. Thank you.